Hey everybody, it's John here, and in these series of videos we're going to learn about logarithmic functions. Now, a logarithmic function is one. This is the notation. So I feel like the notation is the most difficult part of this for most people. It's a notation that's new and it's different. So basically what we're saying is if we have something of the form y equals log base a of x, which is how you say this, log base a of x. So the of part is what's inside the logarithm. This x is inside the log, sort of like inside a square root is under this symbol. Inside a log is in this area right here. Okay? And just like with the square root symbol, this didn't probably mean a lot to you the first time you learned about it and you had to wrap your brain around it. The same thing's going to happen here. You just have to practice. Practicing using this notation is what's going to help you learn it. So again, if y equals log base a of x, then we know that a equals a to the y. So what we've done here, and it's not like I did it, I didn't come up with this notation. What this means is it's basically a logarithm is just a way to rewrite an exponential equation. But the good part is, notice how y is the exponent here? That's this right here. So a logarithm is a way to rewrite an exponential equation solved for the exponent, which when we talked about exponential functions last week, you saw that there was that bacterial growth problem, and we wanted to know how long would it take for the bacteria to reach a certain number. And it turned out that we were able to find that number because it was a nice even number. But what if we need to find that exponent but we don't know exactly what that exponent is? That's what this notation is for. That's what these logarithms are for. Okay? And we're also seeing here that the this if and only if, which basically just means that we have that this works both ways. So if we have something of this form, we can rewrite it this way. If we have something in logarithmic form, we can rewrite it as an exponent. And that's actually how we're going to start here. So all we want to do, and I'm going to rewrite the definition up here. If we have something of the form y equals log base a of x, that is no different than saying x equals a to the y. Okay? So looking at these, and actually the way that these are written, let's write it a to the y equals x. Okay? So the way that these are written in exponential form. Okay? So these are exponentials. Okay? Exponential form. And this is logarithmic form. But they don't mean anything different. They're just different ways to rewrite it. Just like saying that, let's say y equals the square root of x is no different from writing x equals y squared. These actually mean exactly the same thing. And so that's what this is. Okay? These logarithms are just a way to rewrite an exponential equation solved for the exponent. So in this case, we have 4 to the 3 equals 64, which is a true statement. We just want to rewrite it as a logarithm. So look at what we have. In this case, a is the 4, y is the 3, and x is the 64, just looking at this exponential form up here. So rewriting that, putting the a, the y, and the x into the logarithmic equation, we get log base 4 of 64 equals 3. So we've rewritten this, and notice how the base of the exponent in the original exponential form and the base in the logarithm are always the same thing, okay? So log base 4 of 64 equals 3. This is really saying, what exponent do I raise 4 to get 64? The answer is, I raise it to the third. I raise 4 to the third power to get 64. So this is my answer right here. I just rewrote it in logarithmic form. Okay? So I'm going to recommend that you pause the video and that you try the next two problems on your own. And then I'll go through them together. You can unpause and we'll go through them together. Go ahead and pause now. All right, so the second one we have 1/2 to the 4th power equals 1/16. As a logarithm, that would be log base 1/2. The base is the thing that's being raised to the exponent here. So the 1/2 is the base of 1/16 equals 4. Now notice how if we were writing like on a dotted line, what's inside the log and the log itself are on the same level. So this is on the line and it's big font, and this is on the line and it's big font. The only thing that's smaller is the subscript for the base of the logarithm. Okay, but the way that we've written this is how you would write this as a logarithm. Okay, and then finally we have log base a of 7 equals -2. All right, so I hope that went well. Remember, you can pause and rewind if you need to. Now we're going to go the other way. And again, at the top, I'm just going to write the definition of a logarithm and how it's no different from a to the y equals x. Okay, so now we have the logarithm, and we want to rewrite it in exponential form. So again, the base of the logarithm, log base 3, is the base of the exponent. Those are the same thing. So 3 to the 5th equals 243. That's what that logarithm is saying. It's saying if I raise 3 to the 5th power, I will get this number. And what the left side of this equation is really saying is, what would I raise 3 to get 243? The answer is 5. I'd raise it to the 5th. Okay, so this is my answer in exponential form. Again, I suggest that you pause and try the other two problems on your own, and then when you come back, we'll go through them together. Go ahead and pause. All right, so now we have 2 to the x equals 5, and we have a to the x equals n. So I hope that went well as well. Again, you can pause, rewind, whatever you need to do. So now we can evaluate these logarithms, and I want to do these without a calculator. And the question that I'm always asking myself, since this is the definition of what a logarithm is, a to the y equals x. So if we're just looking at this part of the equation, what that is equal to is the exponent on this part. So what this logarithm is really saying is, what would I raise a to get this value? So what exponent would I raise a to? What is the y that I would raise a to get the value inside the logarithm? Okay, so in this question we're asking, what do we raise 5 to get 25? Well, the answer is 5 to the 2nd power gives me 25. What do I raise 2 to? That's what ballerinas wear. To get 16. And the answer is I would raise 2 to the 4th power to get 16. What power do I raise 7 to get 7? The answer is to the first power. I hope this is making sense, okay? So log base 1/3 of 9. I don't look at this and say log base 1/3 of 9 equals. In my head, I'm thinking, what would I raise 1/3 to get 9? And I know somebody out there is saying, I would raise it to the negative second power. John, raise it to the negative second. That is correct. The negative takes the reciprocal. 1/3 to the negative 2 gives me 3 squared, which is 9. What would I raise 6 to get 1? Right? 0. Anything to the 0 power is 1. And what would I raise 4 to get 1/2? This one's tricky, okay? It might help if I ask you, what would I raise 4 to get 2? And then hopefully that will help you get to the answer here. So I would raise 4 to the 1/2 power to get 2, but then that's 2, not 1/2, so I'd have to take the reciprocal of it, so that means I would want to raise it to the negative 1/2 power. 4 to the negative 1/2 is 1/4 to the 1/2, which gives me 1/2. The square root of 1/4 is 1/2. All right. So I will catch you in the next video where we'll talk about domain and briefly talk about what the graphs of these look like. All right, I will see you then.